So first question. Diagram in the figure shows a cell of EMF 2 volt and internal resistance 1 ohm connected to an external resistance R is equal to 4 ohm. So the value of this resistance is 4 ohm. The question is, what is the reading of ammeter and voltmeter when the key is open? So first, when key is open, it indicates open circuit. And we know that when circuit is open, current does not flow. So the reading of ammeter must be 0 and reading of voltmeter, should it be 0? No. Reading of voltmeter in that case will be same as EMF. Alright, because voltmeter here is connected across the battery. And we know that when current does not flow through the circuit or when the circuit is open, the potential difference across the terminals of the cell is nothing but equal to its EMF. So when key is open, current is 0, but voltmeter reading will be same as the EMF value, which is 2 volt. Now when key is closed, current flows through the circuit, and in this situation, terminal voltage will be less than EMF. So let us find out how much current flows through the circuit. For that, we must use the formula E is equal to I into R plus small r, where capital R is the external resistance, small r is the internal resistance of the battery. EMF 2 volt, current is I, capital R 4, small r is 1. So 2 is equal to I into 5. And its current is equal to 2 upon 5, 0.4 ampere. So this much current flows to the circuit when key is closed. And reading of the voltmeter will be the terminal voltage, which is IR. Current is 0.4 into resistance is 4, that is 1.6 volt. Next question. A battery of EMF 3 volt supplies a current through a circuit in which the resistance can be changed. Okay, so resistance is variable. A high resistance voltmeter is connected across the battery. The current is 1.5 ampere, voltmeter reading is 2.7 volt. Find the internal resistance of the battery. So here once again we can use the formula E is equal to I into R plus small r. EMF is 3, current is 1.5 and internal resistance, okay, that is what we want to figure out. Fine. So here we do not know capital R and we are asked to find out internal resistance. So here we'll have to use a slightly different strategy to find out the internal resistance. Okay, we can use E is equal to V, that is terminal voltage plus small v, potential drop formula, where EMF is given, terminal voltage is given, plus small v. So small v becomes 0.3 volt. And now we can use V is equal to I into small r, potential drop 0.3, current is given 1.5 ampere into small r. So the value of small r is 0.3 upon 1.5, which is 1 upon 5 is equal to 0.2 ohm. Next question. A cell of EMF 1.8 volt and internal resistance 2 ohm is connected in series with an ammeter of resistance 0.7 ohm. Alright, so here ammeter provides 0.7 ohm resistance. Ideally, ammeter does not offer any resistance. Okay, so ideally ammeter resistance must be 0, and hence in the numerical, if ammeter resistance is not specified, not mentioned, by default we will consider its resistance as 0. But here the resistance of ammeter is 0.7 ohm. So we can say total external resistance becomes 0.7 plus 4.5, 5.2 ohms. Now to find the current in the circuit, once again we can use the formula EMF is equal to current into external resistance plus internal resistance. EMF 1.8 is equal to I, external resistance 5.2 plus internal is 2. So 1.8 is equal to I into 7.2. Current is 1.8 upon 7.2, which is 1 by 4 is equal to 0.25 ampere. So current in the circuit is 0.25 ampere. And what is the potential difference across the terminals of the cell? So remember here current is flowing through the circuit. So potential difference across the terminals of the cell in that situation is known as terminal voltage, and the formula is I into capital R. Alright, so current is 0.25 into capital R is 5.2. But instead of taking 0.25, if I take 1 by 4, calculation becomes easy, right? Because now 52 divided by 4 is 13. So our answer is 5.2 divided by 4 is 1.3 volt. So see, it's very easy if you calculation becomes very easy if you convert current which is 0.25 into 0.4, right? So if you try to multiply 0.25 into 5.2, definitely you will get the answer 1.3 volt. But if you convert that into 1 by 4 into fraction and then if you try to simplify, the calculation becomes very easy. Next question. A battery of EMF 15 volt and internal resistance 3 ohm, EMF 15 volt, internal resistance 3 ohm is connected to two resistors of resistances 3 ohm and 6 ohm in series. Alright, so we can draw the circuit diagram like this. First, a battery of EMF 15 volt and internal resistance 3 ohm. This battery is connected in series with 3 ohm. 3 ohm is in series with 6 ohm, and then 6 ohm is connected to the battery. So this is how the circuit diagram looks like for this particular question. Now to find out the current, we must first find out total external resistance. So 3 and 6 are connected in series. So equivalent resistance becomes R1 plus R2, that is 3 plus 6 is equal to 9 ohm. Now E is equal to I into R plus small r. EMF 15, external resistance 9, internal is 3. So 15 is equal to current into 12 ohm, and hence current is equal to 15 divided by 12, that is 1.25 ampere. Alright, 1.25 ampere. PD between the terminals of the battery, that is terminal voltage, current into external resistance. Current is 1.25 into external resistance is 9. Okay, instead of 1.25, of course you can put the value 5 upon 4 into 9, that is 45 divided by 4, which comes out to 11.25 volt. 11.25 volt is the PD between the terminals of the battery. Next question. A cell of EMF E and internal resistance R sends a current of 1 ampere when it is connected to an external resistance 1.9 ohm. So current is 1 ampere when external resistance is 1.9 ohm. So let me label this current as I1, external resistance is R1, and the current becomes 0.5 ampere if the external resistance is changed to 3.9 ohm. Find the value of EMF and internal resistance. So here we know that EMF is I into capital R plus small r. So here if I use the first set of information, that is I1 and R1, I can form one equation. E is equal to I1 into R1 plus small r. So EMF is equal to, current is 1 ampere, external resistance is 1.9 plus small r. Now here you see that for this particular equation there are two unknowns, and of course using just one equation we can't find two unknowns, right? And that is why the second pair of information for current and resistance is given, so that we can form such similar second equation, and then we can use simultaneous equation method to solve this numerical. So let us form the second equation using the second pair of information, that is EMF is equal to I2 into R2 plus small r. So EMF is equal to I2 is 0.5 into R2 is 3.9 plus small r. Equation 1, equation 2. Since equation 1 and equation 2 has same left hand side, we can equate these two, and by equating equation 1 and 2, we get 1.9 plus small r is equal to 0.5 into 3.9 plus small r. This can also be written as 1.9 plus small r is equal to 0.5 is half, 3.9 plus small r. So if I take half to the other side, we have to multiply the left side with 2. So 1.9 into 2, 3.8 plus 2r is equal to 3.9 plus small r. So 2r minus r is equal to 3.9 minus 3.8. So R is equal to 0.1 ohm. Alright, internal resistance is 0.1 ohm. Now simply substitute the value of this internal resistance small r either in equation number 1 or equation number 2 to find out EMF. I am substituting the value of small r here in equation number 1. So from equation 1 is E is equal to 1.9 plus small r. Small r is 0.1. So EMF is 2 volt. Alright, so whenever such question comes, you must first form two equations and then solve those two equations to find out EMF and internal resistance.